All right, we are all set to get started here. So if we manage to go at the same pace I did in an earlier class, my intent is actually to see if we can finish up what I wanted to cover this week in one class, and then we don't have to come in on Friday because we have lots of time after reading week to finish this chapter. So we're going to see if we can get through our introduction to memory and then our start about encoding, which is our first step of our memory process, and we should be able to wrap that up today for the week. So, of course, as we typically start with a chapter, we're going to have a general definition. So memory is another one of those terms that has a little bit of a fuzzy definition. And memory can refer to both the structures and the processes that are involved in the storage and retrieval of information. So when we talk about memory, this could just be the parts of the brain that are storing information or involved in storing information, or the process in general that's going on. And as we go on in this chapter, we're actually going to find that there are a lot of different theories and perspectives and ideas that people have, and some of them care a lot about things like structure, and some of them don't care about structure at all. Maybe they care about what the process is, what helps explain what's going on at all of these different steps. So memory is going to change depending on what people are using it to refer to at that time. So a vague definition because it's going to change based on what we're looking at. And of course, we don't want to confuse memory as the broad term with something specific like a memory, which would be our recollection of a particular event. So lots and lots of fuzziness here. But when we're looking at memory, when we're studying memory, there are typically three main questions that we want to ask. So the first question is, how does information actually get from our environment into our memory? How do we take stuff from, say, our environmental stimuli and turn it into something useful in our brains? We then can ask, how is that information then maintained in our memory? And finally, how can we pull information back out of memory in order to use it? And so these three steps, or three questions, I guess, could also be broken down into broad steps or categories. So how do we get information into our memory? That would be addressing the process of encoding. So how information is initially learned. Storage would be the process of maintaining information over time. That might be a short period of time or a long period of time, but that's how we're going to maintain information. And then retrieval is the last step. How do we pull information out of memory? How do we retrieve it from storage in order to use it for some purpose in the future? So these are going to be our three steps, and we're actually going to focus in on each of these topics on their own. But before I delve into each of these topics, we're going to take a brief detour and actually talk about how we talk about memory. So most of the time when we're discussing memory, we use this idea of searching for a particular item. So if you have a memory that you're trying to find, you might search your mind or rack your brain to see if you can remember that particular event or detail. So we tend to use a lot of search metaphors. So we talk about the process of memory in terms and concepts that relate to searching either a physical or a virtual space. If you've seen the movie Inside Out, where they have all of those walls stacked with little balls of memories, that's sort of a physical space that you could search to find a particular memory. And even the terms that we use, we talk about maybe reliving a particular moment, or bringing something to the front of our mind, or looking for a memory, finding a solution. All of these tie in with that concept of searching for almost like a physical item in a space. And a lot of the terminology that we're going to continue using, even the stuff that we just talked about, where we were discussing things like encoding and storage and retrieval, we use processes that kind of match with our technology. So as technology has advanced, we've started using a lot of terminology that overlaps with computers and other recording devices. So if we think about it, encoding is kind of like saving a file. Storage is like your hard drives, and retrieval is opening a file that you had saved earlier. But the problem that we have with this search metaphor and this way of talking about memory is that it ends up implying that memory is sort of a stationary and stable thing. So a memory would be an item that you put into storage and retrieve later on in an unaltered form. But as we're going to find, memory isn't necessarily that static. We're going to find that our memory tends to change and sort of grow as time goes on. So we can run into issues where our terminology, where some of the ways we talk about memory actually ends up misleading us in our understanding of memory. So that's why we're starting with these topics before we even go into the steps of it. So if you imagine that you've been asked to draw something that is relatively familiar to you. So the texts usually use the example of draw a penny because that's something that is fairly familiar to a lot of people. The problem that we have with this is that most texts are American-centric, so we usually end up with things like this, where it's an American penny. It's not super great for Canadians because A, we don't use American currency, and B, we don't have pennies anymore, so that's sort of a double whammy. But you could imagine this as, what if I asked you to draw a dime, or something like that? And I suppose at some point in our lives, we have probably encountered American pennies. So you have some vague idea of what an American penny would look like. And so from this diagram, this was from an experiment where they asked a whole bunch of people draw the head side of a penny. And so we can see just from this sampling here that there's a lot of different responses. They have some similar elements. They all seem to have a face, though some of the faces are face on. Some of them are facing to the left, some to the right. Some of them have words. They might say 1 cent or the United States of America. They have some numbers, but none of them are identical. So which is accurate? And I can say that even if this was Canadian currency, I wouldn't be able to answer this accurately myself. So if we look at what the results from this experiment were, we can have this table here. So what element are we looking at? So different things that people might have drawn, the words "in God we trust," some kind of minting date, the word liberty, and so on and so forth. And they're divided up into things that are actually on a penny. So the ones in green are things that should have been drawn. And then things in red are things that are not actually on a penny. So they are things that people included but should not have been included. And if we look at the breakdown of the percentage of our participants who included each of those elements, we see that they did a fairly good job of the "in God we trust" and a minting date, but most people did not include liberty. So only 5% of participants knew to include that word. In contrast, more than 5% of people included things that weren't actually supposed to be there. So they included things like 1 cent or 1 penny, the United States of America, and even a Latin phrase. Those were included a lot more often than something that should have been included. So we've run into a situation where people are remembering things that don't occur in this situation a lot more often than stuff that does occur. And so we can do this with all sorts of different things. So maybe you were asked to draw a representation of the globe, or which order are all of the apps on your phone in, or something like that. Things that you're exposed to a lot and should theoretically know, but maybe the accuracy of those memories is a little bit questionable. So that's the point we're trying to get at here. So what's going on where we're not accurately recalling what these things look like? So if we're using our search metaphors, we have this idea of, okay, so you go and you find an image of a penny. You've only ever seen correct pennies. You can't have incorrect pennies because those don't really exist. So how do we have in our storage the wrong image of a penny? What's going on there that led to this disconnect? And as a little bit of an aside, even if we were American or that side of a penny has been consistent for over a century. So if you have ever seen a penny, you have seen that particular orientation. So theoretically, we should be able to do this, but most people, even Americans, cannot. So we end up remembering things that never actually occurred. And so this is our first realization that our memory seems to be sort of a direct recording of the world and we're retrieving something static and stable, but in fact, it's not that simple. So if that searching and retrieving metaphor isn't the best way to talk about this, what's actually going on? What fits better instead? And so we can use the concept of a reconstruction metaphor. So this is the idea that our memory is going to cobble together sort of a useful response out of information that we know and information that we have currently available to us. So this is basically saying that memory isn't something static and unchanging. We're saying that we can put together the story of what's going on or what happened based on information that we have available to us. So it isn't necessarily stable and unchanging. It's going to depend on what we can think of and put together at the time. So our brain is going to make a best guess about what happened in a particular situation whenever we try and remember it. And so we have a very, very good example of this in flashbulb memories. So flashbulb memories are thought to be a special category of memory. Basically, these are events that are so extreme and polarizing that they would sort of entrench themselves in our memory. They would form a really strong emotional connection, and theoretically, it would produce a very vivid and accurate and enduring memory of whatever we were doing at the time of that event. So there are lots of examples of flashbulb memories. I do typically go off on a tangent at this point because it's getting harder and harder to have events that produce flashbulb memories. The issue here is it used to be that things would be reported on the news. And so you'd see it on the news at the same time that everyone else saw it on the news. But now with social media and internet availability, we have exposure to information at lots of different times in lots of different places. So there's a lot less consistency. So you're going to find that a lot of our examples of flashbulb memories are fairly outdated. And I started feeling extra old when I was talking about the most recent and well-studied type of flashbulb memories as September 11th, which most of my students now have not necessarily, they weren't old enough to have a memory of that, if they were born at all. So definitely making me feel old there. Mm-hmm. It kind of, there's lots of stuff that like we don't really know. Sometimes if it's associated with something, that makes it easier to remember. And we'll find that the more connections that we can make between things, the easier it is to remember that stuff. So I find that maybe a particular song or a particular smell brings back really strong memories of something that I wouldn't remember otherwise. But because it has extra connections, it brings something else with it. So there's lots of moving pieces for it. Mm-hmm. It is supposed to be applying to a larger group. I don't know if they have a separate memory for, say, an individual experiencing something intense, but typically when you look at the literature, they talk about events that apply to a larger group. I'm sure that you could have a very similar concept applied to someone if you experience something sort of very intense. And the idea here is that the more intense the emotion associated with it, the more solid this memory should be and more easily retrievable it should be. And so we're going to stick with the concept of September 11th because the other ones that they list, the Challenger explosion, that was in the 80s. I was not alive for that one. And even JFK's assassination, even further back. But we could also talk about less widely accepted ones, but things like where were you when you heard the most recent election results for the US? Maybe that was important enough for you. Or I typically use the example of my last day on campus before the first COVID lockdown. I have a fairly vivid memory of that because I was on campus and they had kept the department open specifically so that one of my cohort could defend her PhD. So she defended the day that everything shut down. So I have a nice vivid memory of that. So we can have lots of different things. It just gets harder and harder to have flashbulb memories. So don't be sort of offended that they're the most recent one they typically talk about in texts is from 2001. But with psychologists, we tend to think about events as sort of useful for future studies. So with COVID, you might have started seeing lots of emails about surveys, looking at how life has changed as we switch to online learning and things like that. Psychologists tend to be opportunistic. We make use of information that's available to us from other sources. So when September 11th happened, a lot of psychologists were like, we've been studying flashbulb memories in these older things. This event is going to be intense enough and universal enough that it's going to be a flashbulb memory. So let's start interviewing people. Let's start asking these questions so that we can get a long-term study on the accuracy of this memory over time. And so they started interviewing people the same year within sort of days or weeks of the event occurring. And then they did follow-up studies. So they had the same people come back a year later, 5 years later, 10 years later, now 20 years later. And they could ask them the same questions. So maybe ask them, like, what do you remember? Where were you? Who told you? What do you remember seeing? All of those things. And then researchers can keep detailed records of what events you describe, what details you include, and then we can look at how those details change over time. And so the next slide here is actually looking at the output from one of these such studies. So our first section here with the bar graphs is looking at two different surveys, Survey 2 and Survey 4. So Survey 1 would be right after the event. So that's our baseline. So looking at Survey 2, that would be 1 year later, how much has their story changed? And Survey 4 is 10 years later. How much did their story change versus that baseline the first time? And so along the bottom there, broken down into the two different surveys, we have number of discrepancies or how many things have changed, ranging between 0 and 6. And then up on our y-axis, we have the number of participants who scored each of those. So basically just a record of frequency. And so we can see that some people made no mistakes. Their story was consistent the first time as it was a year later. Some of them made up to 5 errors. So they had 5 different details in their story that changed in the course of a year. But on average, most people score with about 2 errors. And interestingly, even if we come back the 10 years later, the data doesn't look that different. And in fact, there's no statistical difference in this distribution here. So people are pretty much the same amount of accurate versus inaccurate at 1 year versus 10 years, which sounds kind of weird. What's going on that they're sort of having that consistency in reporting across long periods of time? And so that we can look at our next graphs or our next set of graphs. And the one that's labeled A for consistency, that's looking at 3 different surveys. So we still have Survey 2 and Survey 4. So 1 year later, 10 years later. But now we have Survey 3 as well, just an extra data point. And so that is 5 years later. And so we're recording there proportion consistent. So instead of with our first bar graphs where they were saying how many discrepancies were they, they're framing it the other way around with consistency. So how many of the details that they reported the first time are consistent the second time? So if you scored 1 on consistency, then if you gave 10 details, all 10 were the same. If you scored 0, then none of your 10 details would be the same. And we see that people tend to score at about 60% consistency. So only about 60% of the details that they provided stayed the same. But that holds across 1 and 5 and 10 years. So we see about the same amount of consistency overall across large periods of time. So their sort of inability to provide the same details holds across multiple years. So they are consistently inconsistent in their recollections. And then if we look at our confidence, that's another interesting one. We see that the line is fairly flat again. And if we look at that, we're seeing how confident they are in their response. So that's probably on a scale of 1 to 5, how sure are you that this is what happened? People tend to score very high on that. So they are very certain that they're giving you an accurate account, but the details don't match almost half of the time. So that's kind of interesting, and it shows us that these flashbulb memories, even though we are certain of our recollections, they do tend to change and differ from the first telling to the next telling, and we have about the same amount of inconsistencies over time, which is kind of cool. So we have very high consistency in our accuracy, even though we tend to be very inaccurate. So what's actually going on here? Why is this happening? And the first thing I want to point out is what's going on here is that flashbulb memories, though we are more certain that we are accurate and recalling things, are actually no different from regular memories. Flashbulb memories are just they stick out in our minds, they feel more salient, but they're not actually special or different. They're the same in terms of inaccuracy as any other kind of memory. And the reason why is because, again, memory is a reconstructive process. So we put together our best guess of what happened based on available information. So we use the information that we have at hand to figure out what happened. And a lot of times with things like what's studied in our flashbulb memory studies involve you telling someone a story. So the first time you tell that story, you would be remembering whatever details were most important the last time you thought about it. And then when you came back a year later, now when you think back, maybe you're going to remember the story that you told, but not the actual events that happened. So we start to see this disconnect between the actual events, and you instead remember whatever constructed event you put together when you first recalled it. So the available information at our time of recall is important, and we actually find that if you are presented information in a particular way, we can change your recall ability. So we find this being especially problematic with things like eyewitness statements. So even though we have very high certainty that people remember what they saw, there are tons of studies that show that people who report seeing particular events or even particular people at a location can be very easily misled. So eyewitness reports aren't actually that accurate. And it's because memory is reconstructive and we can shift what people think they remember if we present them with alternative information. And in most cases, we can produce an accurate enough representation of what happened to function. So we do a lot of very routine things. We do the same thing over and over again. I typically drive the same route on my way to campus every single day. So if you asked me about a particular part of my route, I might not be remembering what happened today. I might be remembering what happened a week ago, 2 weeks ago, because it's all the same. But it's not wrong because it's always the same route. I just might not be using exactly the right information to construct it. Though we do, again, have issues where sometimes we don't have an accurate reconstruction. Sometimes we have inaccurate recall because maybe information is missing, maybe we've put stuff together incorrectly, or maybe we've been misled and exposed to other information that sort of messes with our reconstruction. So we just want to keep in mind that memory isn't that solid and static event. It's something that's going to be growing and changing. And we're going to keep revisiting this concept as we move through this chapter, but I wanted to make sure that we took some time and talked about it early on, just so that we have that in the backs of our minds as we're working through it. Next, we're going to talk about encoding memories. So this is the first of our 3 steps: encoding, then storage, then retrieval. So encoding memories is that initial process. How do we form a memory code? So how do we initially learn that information? And you're going to find that there are a couple of parallels here, especially with our talk of, say, cognition, as well as sensation and perception. We're starting to make connections with some of our earlier chapters. But if you think back to the sensation and perception chapter, we talked about a concept called transduction, where we took stimuli from our environment, they interacted with our sensory receptors, and they were turned into some kind of neural code that could be brought to our brains in order to be processed and perceived. Encoding is the same basic concept, where we look at information that's been brought in from our environment, and we're turning it into some kind of memory code, something of meaning that we can store away for later. So this is how we're taking information from our environment and turning it into something that could be stored in the future. So encoding is we're turning it into code that we can remember later. And sometimes you'll see people talk about the issue of the encoding problem. So how do our brains obtain the information that they're going to store later for retrieval? How do they decide what is important? How do they decide what we're keeping and what we're ignoring? So sometimes you'll see it referred to in that way. So in order to initiate this whole process, in order for something to become a memory, to be put into storage and retrieved later, we first have to get past that first hurdle of turning it into something that could be stored later, or stored for later. And so the first thing we want to look at in terms of encoding is our sensory memory. So sensory memory is the system that keeps information translated by our senses in a briefly active form, it keeps it briefly active in an unaltered form. Whew, words today. But this is basically saying that when we're bringing information in from our environment, we aren't necessarily perceiving or paying attention to absolutely every stimulus that's coming in. We're hearing things in the background and we're filtering them out. We're ignoring them because they aren't relevant. Maybe we're feeling things that we don't need to be feeling, or smelling things that aren't relevant. So this is when we have that sensory memory. So we have information coming in, our sensory receptors have detected stimuli, and we're going to get to that point where we decide if we're going to be using that information for later. And so we can think of sensory memory almost as a buffer. So it's going to hold on to that information from our sensory receptors until we can decide if we're going to use it or not. So we have 2 big types of sensory memory that we talk about. The first is our iconic memory. So this deals with our visual sensory memory. So this is information coming in through our eyes. And we can call this, so icons would be the things that we are remembering very briefly from our sensory receptors in our eyes. And so this is kind of like when you're walking through the halls and you have a moment of, wait a second, what did that person's shirt just say? So you saw it, you didn't process it right away, and then as you were walking, you kind of caught up with your own visual system and went, wait, that was interesting or weird or attention-grabbing in some way. So you have that brief ability to backtrack to something that you had just seen to then figure out that, okay, now I need to pay attention to that. We also have echoic memory. So this is our auditory form of sensory memory. So we can think of sounds as echoes, where we hold on to that sensory information for just a moment. I know that I am really, really bad for this one. So maybe someone comes up to you and starts talking to you. And they started talking before you were paying attention. So you stop them and you say, wait, what? But as soon as they go to repeat, you know exactly what they said because you sort of rewound the conversation in your head and you figured it out. So you relied on your echoic memory to kind of pull back the last couple of seconds of that process. And so this is really useful because we don't necessarily know that things are important right away. So this gives us that buffer time to figure out, okay, I need that information or I don't. And again, we're going to start seeing with memory that a lot of this stuff, we don't necessarily know exactly what's going on, hence talking about a lot of different theories, a lot of different concepts. So we're going to be focusing in on iconic and echoic memory because those are the two that are most well understood. So we're going to be sticking with visual and auditory information, even though we could theoretically have sensory memory for other senses. These are the two that we care about. But, okay, so we can say, yeah, that makes sense. We can tell stories where, we have a buffer of our visual information. We have a buffer of our auditory information. But how the heck do you study that? And so one of the best ways that we can do that is kind of like an experiment like this one on the figure here. So if we look at the first step, that's labeled as fixation. In a lot of psychological studies, this is basically there to make sure you're facing in the right direction and you're looking at the right place. You could theoretically do this with an auditory setup, but it's a lot easier to visualize with a visual setup, so that's what we're using here. So step one is have a participant and have them face and look at a particular point on a screen, usually done on a computer. Next, we have a display, an exposure to a bunch of visual stimuli. So here we have 3 lines of 4 different letters each. And so they could randomize the letters, you could include numbers, you could include a couple of different things here. Letters and numbers are the most common. So that would be flashed on the screen for just a fraction of a second. So here it's listed as 1/20th of a second, so very, very briefly. But entirely enough for our sensory receptors, for our visual receptors to pick up on that information. Then we would be asked, what did we see? And there's 2 different conditions. The first would actually stop after the display portion, and they would just say, report as many letters as you can. They might ask you to report locations as well, but we would find very, very quickly that we wouldn't be very accurate at reporting the whole thing. So a full report is not going to be accurate, and that might be some issues with our short-term memory. It might be some issues with our iconic stores. It's a little bit complicated there, but we're not typically good at full reports. So instead, most of the time, these studies will use something called a partial report, which is basically they introduce a tone, usually a high, medium, and low pitch sound. And so if they play a high pitched tone, they want you to report the upper line. Low pitched tone is the bottom line. And that way you only have to report a single line. So 4, in this case, just 4 letters, which is quick enough that, yeah, you could probably report everything that you had just seen. And so they would display this tone after a certain amount of waiting. So 0.15 of a second, 0.3 of a second, 0.5, or even a full second. And by varying how long you wait before they display this tone, we can look at how quickly your iconic store starts deteriorating. And so we find that we're very, very good at these partial reports. If we're only asked to report a single line, as long as it's less than a second. We're pretty good to sort of about half a second or so. And we see some variability here. But this tells us that our iconic store is going to be accurate at the level of fractions of a second. Anything longer than that, and we really can't hold on to that information accurately for any length of time. If we were doing this with an auditory cue, so if they set up something kind of like this using audition, we're actually a little bit more accurate with our echoic stores for longer periods of time. So echoic would be in the range of like a second or two. So iconic, visual, is fractions of a second. Echoic or auditory is going to be a couple of seconds, so 1 or 2. And I already kind of said this, but we're much better at those partial reports than full reports. And that's just sort of the mechanism of what we're being asked to recall at any given time. So there's lots of moving parts we can evaluate with one of these setups. So you could vary how many lines are there, how long are those lines, how many letters on each, and things like that, just to get at a specific of how much we can hold on to. And typically about 4 items per line is about optimal. And we'll kind of start seeing why in just a moment here. So of course, if we're thinking about encoding, if we're thinking about bringing things into our memory, we probably have made some connections already with our earlier chapters talking about attention. Things that we are currently aware of, things that we are consciously aware of. That's definitely going to affect what ends up being stored in our memory for the long term. So attention plays a large role here. If we are not paying attention to something, and if something is not salient enough to grab our attention, it's never entered into our conscious awareness, and we're very unlikely to ever remember it. So if we see something and don't register that we saw it, we're not going to be able to tell someone later about having seen it. And so when we were doing our chat about awareness and attentional blindness or inattentional blindness, we showed that video of people passing basketballs. So you might be able to recall the passing basketballs, but if I didn't sort of pause it and have it go back and they showed you the gorilla in the middle, you might not have remembered that part of it. You wouldn't have been able to report that that happened if we didn't bring it to your attention. So attention and awareness play a lot of a role here. And because we have that little bit of a buffer with our iconic and echoic stores, we can actually have a little bit of variability in when we decide or select what we do or don't pay attention to. And so there's a couple of different theories, and we won't go into too much detail on them. But the basic idea is that we might have early filtering or late filtering depending on the situation. And I'm actually going to scroll to this page here so that we can see the visual that goes with it. So this diagram is looking at sort of the progression from a stimulus coming in from our environment and then over to some kind of behavioral response where we might react to that information that's come in. And so the first step is sensory detection. Is it registering on our sensory receptors? Have our eyes seen that thing, or did our ears pick up on it? In the middle, there's some kind of recognition. We assign meaning to it. So that would be the stage of perception. So we've brought in information and now we've assigned meaning to it. And then afterwards, we would sort of decide what kind of a response is required based on that information. And so we have a couple of different models. We can classify them as either early selection models that would say once we've detected it, we would immediately decide if we pay attention to it or not. But there's also late selection models. So that would say that we have a filter that comes a little bit later. And this tends to line up really nicely with those ideas of iconic and echoic stores, where you can say, wait a second, I did just hear something, or I did just see something. Let's pay attention kind of back in time. So we can sort of have that shifting of where the filters go, where are we paying attention? And most of the recent evidence isn't going to say that it should be always early or always late. Usually it's somewhere in the middle. And we're going to find that consistently in this course, where there's usually 2 theories proposed and we find a happy medium, or at least a place where we can all agree to disagree. And so, yeah, we can have that decision of what do we pay attention to or not. Maybe you hear your name and it catches your attention. So you can sort of rewind back in your echoic store. What are they talking about? Is it something interesting? Do I want to pay attention? Am I going to react to it, or do I keep going on what I'm doing now? So that's kind of where this is talking about. So where do we decide if we pay attention or not? And if we do pay attention, then it can become part of that memory process. All right, the next section I want to talk about is our immediate memory. Now, this is another one of those places where there's a bunch of different terms and people tend to disagree on what terms they use and how they use them. I'm using the concept of immediate memory to refer to both our short-term memory and our working memory. Some texts might break it down into short-term memory as one thing, working memory as another, and talk about them completely separately. I have also seen texts that squish it together and call it short-term working memory, or STWM, all at once with no distinctions. So I'm kind of going with a middle ground. I saw the term immediate memory that is basically all of our systems that actively hold a limited amount of information so that we can do something with it. And it includes both short-term and working memory. I kind of like this term. So this is our more general description. Immediate memory is our big, broad category. We can also talk about short-term memory as holding on to things, holding on to information currently in order to sort of have them in our memory. Working memory is where you actually work with information. And we're going to revisit these topics a little bit more down the line. But working memory is where you would have information not just to hold it, but to do something with it. So just the distinction between the three terms. They're all very, very similar, but they have slightly different specifics. And we can think of our immediate memory as the contents of our consciousness. So again, back to the consciousness chapter where we would talk about our consciousness, our pre-conscious, our unconscious. So this is the stuff that we are actively thinking of in the moment. And so we can talk about three different characteristics of our immediate memory. So representation is looking at what kind of information that our system is holding on to. We can look at the duration, how long we can hold on to that information before we forget it. And then capacity, which is how much can we hold at any one time. So we're going to talk about each of these and how we can modify them or sort of make exceptions to each of them. But first, we're going to talk about representation. So what kind of information are we holding on to? And as I said, we're focusing in on auditory and visual stimuli the most because those are the ones that we've studied the most. Those are the ones we're most certain of. So we can talk about representation as an internal inner voice, almost like your own monologue. So if you were given a grocery list from your mother, you might say those items in your head to remember them. So if you have to go and get bread and milk and cheese, you might repeat those words to yourself, sort of an internal running monologue. We might also have visual information stored. So our inner eye. So instead of the words and hearing the words, maybe you see images. So you see a loaf of bread and a carton of milk and a chunk of cheese. Maybe that's how you sort of hold on to that information. And we can have other kinds of information, which we'll talk about a little bit more when we look at our working memory in particular. But these are the two big ones. For duration, of course, we want to know how long we can hold on to information. So how long can we remember that grocery list? And there's a bunch of research, and depending on how things are set up, there's a lot of variability in what people think is going on. So when we're looking at how long we can hold information before we forget it, it's going to depend. Again, so it can be as little as 3 seconds before we see a drop-off in performance. So after as few as 3 seconds, we can start losing items from a list that we were just given. And we can hold on to things for almost up to 20 seconds. 20 seconds is sort of that upper limit that we can hold on to something before we lose it. And actually, if we switch to this next slide, if we look at, so this graph is showing seconds between presentation and recall. So if you were given a list of items, or here they're talking about percentage of letters recalled. So if we had items flashed on the screen or whatever, and we would have, at the 3 seconds, we have pretty good recall. We can recall most of them. But at 3 seconds, you start seeing that drop off. We can still recall some up to about 20 seconds, but after that, there's basically no recall. So that's what we mean by saying there's sort of a variability there, where we start forgetting things after 3 seconds, and by the time we hit that 20-second mark, nothing is left. But there's usually going to be what's called a forgetting curve of how much we lose at different times.
So if you're like repeating those letters in the get-go, would you be able to remember longer than 3 seconds?
Yes, and that's called rehearsal. So the process of rehearsal is where you repeat those things over and over again. So maybe you repeat your list, or you repeat the letters that you just saw. So in most of these studies, so in that graph here, they would be, basically they'd present you with something and then either distract you right away with something else or ask you immediately to report what happened. So if there's a 3-second delay, then maybe they'd show you something else that would keep you from rehearsing things in your mind. For a 20-second delay, they'd probably have you do a math problem or something like that. So they would time exactly how much of a distraction you had before you were then asked to repeat things. And so they have different tricks to keep you from rehearsing. But if you rehearse, you can hold stuff in your short-term memory pretty much indefinitely, which is kind of cool. And we actually have different kinds of rehearsal that have differing sort of effectivenesses. We have maintenance rehearsal. So what we've been talking about, where you just repeat the list over and over again, that would be maintenance rehearsal. So you just take that information, you maintain it in your memory by saying it over and over again. But I have still got the ability to remember our list, even though it's been more than 20 seconds. I still know that we were supposed to go and get bread and milk and cheese. And it's because I'm using elaborative rehearsal and I'm making connections with other bits of information. It also helps that I use the same list every year, so it's not so much short-term memory as longer-term stuff, but I make connections between things. So maybe I'm thinking about, okay, bread to make sandwiches, and milk to drink, and cheese to go on the sandwiches. So I'm adding extra information, I'm elaborating on my list, and it helps me remember it a little bit better. It also helps prevent you from starting to lose items as you get distracted. So that's a duration. And then the last one we want to talk about is capacity. So how much information can be held in a memory system at any one time? So how much can you hold in your memory at once? And there's a lot of disagreement, again, on this. So typically we'd consider it whatever you can rehearse in about 2 seconds. So if it takes you longer than 2 seconds to run through your list of items, it's probably too many things to hold in your memory for any length of time. So our capacity is going to be about 2 seconds worth of information. And typically we're going to see it referred to as 7 units plus or minus 2. So if you're remembering numbers, we would have about 7 numbers, or letters, 7 letters, or a grocery list, about 7 items. So units of information, 7 plus or minus 2. Some of us are on the lower end of that spectrum. I know 7 is a lot of things, and I am not good at that. I used to joke that my friend and I, watching us try and dial a phone number was the best 10 minutes of your life to get us to put the numbers in the right order. And it's because it took both of us to put the numbers in the right order. But we'd have a lot of trouble holding on to information. Some people are really great at it. Some people can hold information in large amounts and are great at repeating things, and they have a much larger capacity. I am not that person, which is unfortunate. But we can also refer to this capacity, or the number of things we can hold, as our memory span. So the number of items we can hold in that sort of 2-second recall ability. And of course, we can extend our capacity using different tricks. As per usual with memory, the more things we make connections with, the more meaning we can assign to something, the easier it is to remember. So we can use a process called chunking in order to group familiar stimuli in order to store them as a single unit. So if we look at the first line here, those are groups of 4 letters. Those don't have any meaning associated with them. That doesn't help at all. Out of all of that, I might remember the last 4. I might remember best because that's a word that makes sense to me. So that's all I would retain from that list of letters. But if we grouped them a little bit differently according to meaning, so now we can group them into longer clusters of letters, but now they're words that have meaning, I only have to remember 4 words. That's not bad at all. That's not like 20 letters. That's just 4 words. So we can chunk things and cluster them together so that we can remember more information at once by using little mental tricks. And we'll talk about more of those little tricks when we come back to the topics as we move through the chapter. Perfect. All right, so our timing is phenomenal. That's what I wanted to finish so that we can start with working memory and how it differs from general short-term memory next time. But we've covered what I wanted to cover this week in one class, which means that you guys get Friday off. I'm going to use Friday to mark your midterms. So I will be posting your grades on Moodle as soon as I have everything worked out. So hopefully by the weekend. But yeah, so I will send out an announcement so you don't forget and accidentally come in. But I will see you after reading week. So please don't forget that it's reading week. And I'll include that in the announcement as well.